Welcome back to the Diesel Page. My name is Jim. This video is the first in a series of Duramax service topics and serves as an introduction to learn what tools, tips, and supplies you'll need when working on your Duramax 6600. Coming soon will be a set of separate videos showing you how to correctly replace the fuel injectors, the head gaskets, water pump, and a lot more. Subscribe to our channel so you don't miss them. Only GM's recommended best practices and methods will be shown in this video series. Plus, you'll learn how to save money, produce the best possible repair, and do the work using the easiest to follow set of instructions on YouTube. Nearly 100 miles from home, this photo was snapped on August 10, 2023, looking north from an overlook situated above the southern end of beautiful Flathead Lake here in western Montana. This camping and fishing trip was possible only because a new set of head gaskets and injectors had been installed a couple years prior, which made the truck a reliable member of the family again. If you're like me, you want to be successful when involved with a complex or costly repair, and you don't want a do-over. We'll show you how to be successful the first time and for the least amount of money. The Duramax 6600 is a complex engine that can be expensive to work on. If your older Duramax needs a fresh set of injectors, head gaskets, and a water pump, the 50-plus hours of shop rate labor could very well push the cost of repair beyond $10,000 if you hire the work done for you. Doing the exact same repair yourself would reduce the cost to a total of only about $3,500. This is why our Duramax service videos exist. This guide series will help you succeed in doing the work correctly the first time, and you'll save thousands of dollars by doing the work yourself. The motto here is do it once, do it right. I've been a professional automotive writer and photographer for more than 30 years. The information contained in this video series is the result of my having owned a Duramax 6600 powered truck since about December of 2000. I visited the D-Max engine production facility in Moraine, Ohio a couple of times, and I've spent time with the engineering team at GM Powertrain in an effort to learn more about the engine. General Motors trusted our work here at the Diesel Page so much that in October of 1999 they shipped two of their early Duramax Allison prototype trucks here to Montana, where I became the very first person outside of GM to test and review the new Duramax Allison trucks. Producing GM diesel-related how-to guides, product reviews, and feature articles is what we do. We've also operated the Diesel Page website and bulletin board forum since 1997, and our troubleshooting and repair guides have been used even in Wyotech classrooms. Experience you can trust. Let's get started. I used about every tool in my toolbox at some point while replacing the cylinder head gaskets and replacing the fuel injectors, looking for an easier way to remove or install a piece of hardware. Some tools helped and some didn't. However, to go along with this photo, what follows is a description of the mostly non-typical tools that I found necessary or helpful when replacing the Duramax head gaskets, diesel fuel injectors, and water pump. Number 1. This is a Manley wrench. It's a 3/4 inch drive breaker bar that is 36 inches long and was purchased from Harbor Freight for about $80. A 100-pound pull will put 300 foot-pounds of torque on the 3/4 inch drive 36mm 12-point impact socket shown here. Mechanics have told me that the damper bolt appears to tighten all by itself over time, well beyond the 260 foot-pound torque specification that the bolt was originally torqued to. Whether that's true or not, this breaker bar and impact socket will handle anything any damper bolt can dish out, even if you need to put a cheater pipe on the end of the wrench to gain even more leverage. While not necessary for a head gasket replacement, this 3/4 inch breaker bar and 36mm socket are necessary for a water pump replacement. because one of the water pump bolts is inconveniently located behind the harmonic damper. Note, you'll likely break your half-inch drive breaker bar if you try loosening the damper bolt with it. Number 2. The 24-inch long half-inch drive click-type torque wrench shown here is a fairly good one. A Sears Craftsman model that covers the range of 24 foot-pounds to 250 foot-pounds. I relied on this torque wrench for most of the work. However, many of the smaller fasteners are torqued to less than about 20 foot-pounds, and some of the smaller screws and bolts are even in the range of inch-pounds. Number 3. This 3/8 drive torque wrench covers the range of about 10 foot-pounds to 80 foot-pounds and was purchased at Harbor Freight. My primary half-inch drive torque wrench couldn't be used for the 10 to 20 foot-pound range of torque settings. This one can be, and this is where I used it. Number 4. This is another Harbor Freight torque wrench, an even smaller one, but in the 1/4-inch drive range, and which covers the range of 20 to 200 inch-pounds. This is used for torquing the 5mm Allen head screws that secure the upper and lower valve covers, as well as a few other smaller fasteners. An accurate torque setting for these screws is important to keep from twisting the screws off or stripping the aluminum threads. I also have a beam deflection torque wrench, not shown, that covers the range of 0 to 600 inch-pounds. I spent some time comparing the Harbor Freight torque wrenches against each other and to my other more reliable torque wrenches to evaluate their calibration accuracy. I found that the Harbor Freight torque wrenches worked well enough to at least within 10% of their setting. Once through the evaluation process, I could compensate for a few percentage points. Using the proper torque values for each fastener is vital. Don't try to do any of this without using a torque wrench. Buying quality tools is almost never a wrong choice, but I bought the Harbor Freight torque wrenches because they were cheaper, and a few of their other tools because I knew I might not use them much after completing these projects. Number 5. Shown here is a 1/4-inch drive metric socket ratchet driver set. This is a Sears Craftsman set that I've had in my toolbox for many years. A quality set that I found quite useful while replacing the head gaskets. The shallow and deep sockets cover the range of 4mm to 14mm. The tiny ratchet would fit into areas the larger tools couldn't, and sometimes better suited for the more delicate work, such as the electrical connections on the injectors, or the electrical connections to the glow plugs, etc. Number 6. Pry bars. You'll need a pry bar to loosen the upper valve covers from their silicone bond once the screws have been removed. And a pry bar is useful for several other areas and steps outlined here in this guide. This particular pry bar was purchased from Harbor Freight. This style pry bar was intended to be used to help motorcycle owners remove and replace tires, but they work great for automotive work too. Number 7 and number 8. You'll need a selection of 1/2-inch and 3/8-inch socket extensions. The 3-inch lengths are most useful, but having a range of extensions up to 12 inches for both the 1/2-inch and the 3/8 drive will be a big help. Number 9. In addition to a full set of deep and shallow metric socket sets, you'll need both a 12mm and a 17mm 1/2-inch drive 12-point socket. The 12mm 12-point socket is used to remove and replace the bolts that secure the turbo up pipes to the exhaust manifolds. These can be tough to loosen, so you'll need the 1/2-inch drive socket to power through it. The 17mm 12-point socket is used to remove and replace the factory Duramax head bolts. This socket needs to be able to handle up to 200 foot-pounds while breaking the head bolts loose. These factory head bolts require a 12-point socket. Number 10. As already mentioned, the 12-point bolts used to secure the turbo up pipes to the exhaust manifolds can be tough to remove. I found that a 12mm 12-point box end wrench in both the 5.5-inch and 8-inch lengths can be useful to help you remove the third bolt, the one closest to the engine block, on each side of the engine. Additional tips to help remove and replace those bolts will be discussed as part of the R&R procedures. Number 11. These are just 3 of the several socket extension adapters I found useful. By adapter, I mean like going from 1/4 inch to 3/8, 3/8 to 1/2 inch, and as well as adapters going back the other way. You'll use these adapters quite frequently. Number 12. Crow's foot wrenches are used in combination with the torque wrenches to torque the 3/4 inch or 19 millimeter steel fuel line fittings and the 14 millimeter rocker arm adjuster lock nuts. Number 13. I bought a 3-piece drill driver combo, 1/4 inch, 3/8, and 1/2 inch drive adapters from Harbor Freight that allow my battery powered drill driver to run in and out many of the bolts and screws used in the Duramax. I would set the torque value on the drill driver to a low value, like number 2. That was little more than finger tight in torque. Then I'd run in the head bolts or studs or the Allen screws in the valve covers. Be very careful when using a power tool of any type to tighten a fastener more than finger tight, or use a power tool to break loose or torque the Allen screws used in the valve covers. Be very careful with the Allen screws. They are easy to cross thread, easy to strip, and the hex Allen heads are easy to round out if the hex tool isn't fully engaged in the screw head itself. The temptation here is to use a power tool to save time and effort, but breaking a screw off or ruining a hex head at the rear of the engine will add hours and more frustration that you want to deal with. Number 14. The special toothed tools shown here, as well as the 36 millimeter impact socket discussed earlier, are included in the Lyle number LS22100 special tool package. The toothed tools are used to lock the engine's flywheel or a flex plate, depending on whether you have an Allison or a ZF 6-speed, to allow you to remove and replace the harmonic damper bolt and the damper, which is necessary when replacing the water pump. The bottom tool in this stack of 3 pieces is an LB7 injector removal tool. An internet search will offer plenty of suggestions for where to purchase these tools, like Amazon or eBay. These tools will be discussed in more detail as the removal and replacement process unfolds. Clip a warning flag to the truck's steering wheel whenever a flywheel lock is in place. This lock must be removed prior to attempting to start the engine. Number 15. This is an LB7 injector cup removal tool, Kent Moore J-45910. You'll need this tool to remove the stainless steel injector cups from the aluminum heads. I recommend not trying to make a tool using YouTube videos and concrete anchors. The tool shown here, or any one of a half-dozen others you might find on the internet, won't damage the cups, thus making it possible to reuse them, saving you a lot of money in the process. Believe me, the tool costs way less than replacing the injector cups. I paid about $90 for the one shown here, but I saw a few others on the internet that were advertised for quite a bit less. If you choose to look at less expensive options, just evaluate whether they operate similar to the one I used for this guide series. Number 16. Here are 3 ratchet wrenches I found useful. 1/2 inch drive, 3/8 drive, 12 inch long with a swivel head, and a short 3/8 drive ratchet wrench. I recommend buying good ones here because you'll be using them a lot. 17, 18, and 19. You will need a good quality metric Allen head driver set in both the straight shank and ball driver shank, particularly in the 5 millimeter for the Allen screws used to secure the valve covers, and the injector hold down bolts on the LB7 require an 8 millimeter driver. In addition, you'll need a regular 5 millimeter L-shaped Allen wrench to remove a couple of the valve cover Allen screws at the rear of the engine nearest to the firewall. Never use a ball driver to crack loose or torque these screws. The 5mm ball driver is very useful once you've cracked loose the screws with a straight shanked driver. Breaking a ball off in a hard-to-reach screw would be cause for some harsh language. Don't scrimp on the quality of the Allen drivers. Number 20. During the reassembly of the cylinder heads, you'll need to reinstall the stainless steel LB7 injector cups. You'll need a driver to drive the cups into the head. The GM service manual suggests using a brass drift. I already had a glass-filled nylon rod of the correct diameter, which is 0.825 inches, and that worked well for me. Don't try to use anything made from steel. You could use aluminum or even a hardwood dowel, but seating the injector cups requires some amount of impact to get the cups seated, and you don't want to damage the cups or the cylinder heads. Number 21. I found that my 3/8 air ratchet was useful for removing a couple of the hard-to-reach bolts on the engine in areas where there was a little room to swing a wrench, but I could get this air ratchet in a short socket into the area. Not essential, but certainly of value. Number 22. This is a hardware store paint scraper that I carefully used to remove the bulk of the old gasket material from the head and the block deck gasket surfaces. Don't use a razor blade scraper or a grit wheel to remove the gasket material. The one shown here uses a steel scraper blade that you can sharpen or dull as necessary using a flat sanding block in an effort to make the edge flat, or remove too many sharp edges or nicks or defects in the scraping edge. The old gasket material and carbon buildup will come off easily, so go lightly when using the scraper. Practice on something disposable before committing its use to the aluminum cylinder heads. Number 23. This is a 1.9 inch or 48mm spanner used to loosen the large nut on the fan clutch. Lots of options are available on the internet. You could even make one using a steel plate. The following image shows another option for holding the fan pulley from turning if the large nut cannot be loosened otherwise. Number 24. Always have some nylon ties and electrical tape on hand. You'd be surprised at how useful this will be. Number 25. This is an automotive rubber mallet, and it's useful in a lot of ways. For example, use it to smack the end of the wrench to loosen a stubborn nut or bolt instead of bruising the heel of your hand. I use this mallet and a 14mm box end wrench to loosen nearly all of the valve adjuster lock nuts. This is a magnetic extendable wand and a claw part picker. Trust me, you'll get better at it over time, but till then you'll more than likely drop fasteners and tools in hard-to-reach places frequently. A magnetic pickup tool and a claw grabber tool will come in handy. You'll thank me for suggesting them. These tools are each about 24 inches long when fully extended. I bought these from Harbor Freight. Fuel supply and return line quick disconnect. The fuel supply and return lines use quick disconnect fittings. Shown here is a set of tools that allow disconnecting the 1/2 inch fuel supply line and the 3/8 inch fuel return line, found above the rear of the driver's side valve cover. The aluminum sleeve on each tool can be slid into the fitting shown here, whereby the spring tabs are released, allowing the fuel line fitting to be then separated from the line it connects to. A quick spray from a little WD-40 can help make the process easier. These tools and these quick disconnect fittings will be discussed in more detail farther on. The disconnect tools shown here were made from aluminum and were purchased as a 4-piece set from Harbor Freight. Only the 3/8 inch and the 1/2 inch tools shown here are necessary. GM said in a service bulletin dated October 30th, 2009, that for surfaces that have corrosion or pitting, wrap a piece of flat steel 4 inches by 2 inches or larger with 600 grit wet grade sandpaper. Now this is what you need to prepare the aluminum heads and the cylinder block for new head gaskets. After reading the GM Technical Service Bulletin about how to prepare the head and block deck surfaces for new gasket, I wondered what I would use for a sanding block. I didn't have anything that would qualify as precision flat, so I contacted a local fabricator who possessed the tools and the know-how to create one. The above photo shows what he was able to produce on his milling machine. This is a flat 1/2 inch thick 3 inch by 4 inch steel block. This was made from 1/2 inch chromium steel plate of the type used for silhouette targets. The above machine block cost me about $50, but you could produce a less expensive alternative using a flat piece of steel like angle iron or something else and sand it perfectly flat using wet, dry sandpaper on a flat surface like a table or a countertop or a sheet of glass. Whatever you use for a sanding block, it must be very flat and have its edges rounded and beveled to prevent the block edges from digging into the aluminum cylinder heads. In addition to the WD-40 dry lube shown here, I also recommend you buy a can of the WD-40 lubricant that we're all familiar with. It's going to be useful for all manner of things, including rusty nuts and bolts, but you'll also use it when a time comes to check for leaks in the LB7 injector fuel return lines. I also recommend that you buy 6 large cans of spray brake cleaner. That you'll need more of this perhaps, but this will get you started. Use more if you need to, though always use in a well-ventilated area. Much of the work in replacing head gaskets or injectors requires absolutely spotlessly clean and bone-dry parts. Make doubly sure all of the parts are clean and dry during reassembly that need to be, like the block and head gasket surfaces or the inside of the cylinder heads where the injectors go. Always wear safety glasses when using spray brake cleaner. This is important. Read the safety precautions shown on the cans, and more info on using the spray brake cleaner will appear in those steps that require brake cleaner later in this video series. GM chose to put the coolant drain plugs on the engine block behind the starter motor and other virtually inaccessible locations. The factory drain valve on the lower right rear corner of the radiator is pointed to in this photo. The drain valve is somewhat delicate in nature and it cannot be used to drain all of the engine coolant. If you're careful, you can loosen the drain valve fitting to help drain some of it. The light-colored plastic and clean bucket shown in this photo were used to help keep the coolant clean so that it could be reused. However, to drain more of the coolant, I recommend disconnecting a heater hose that connects to the bottom radiator hose. One end of this heater hose is located near the lower front right corner of the engine, where it connects to an aluminum tube that routes coolant up and around the engine oil dipstick. You can drain most of the coolant using this hose. To reduce spillage, use clamps on either side of the heater hose connection before you disconnect the hose. I use 2 clamping pliers, one on each side of the connection where it can be separated. These clamps were produced for the welding market to hold metal pieces during the welding process. They're cheap and they work great to clamp the heater hoses. I bought these from Harbor Freight for a metal and a roofing project I was working on a couple of years ago. Try not to damage the hoses by using too much clamping force. When removing an engine coolant component that contains coolant, cylinder head, water pump, etc., you'll just have to loosen the bolts and spill some coolant in the process that couldn't be drained or saved via a heater hose or the radiator drain valve. I use a large pan to catch most of the coolant spillage, and in fact a large trash can lid works pretty well for this purpose. Secondarily, I recommend keeping a 7-foot length of 3/8 to 1/2 inch OD clear vinyl tubing nearby as you begin the process to disassemble the various components. This vinyl tubing can be inserted into the top of the water pump once the water pump bypass tube has been removed, or into a coolant passage at the rear of the block deck when a head has been removed, and then siphon out even more of the coolant. I like to use clear tubing as a siphon hose because you can hold the free end up above the radiator, suck on the hose, and see the coolant rise in the tubing. When the tubing is nearly full, put your finger over the end and then lower it into an empty gallon jug or bucket waiting on the floor. This doesn't spill any coolant and keeps it out of your mouth. And if the jugs are clean, you can either reuse or recycle the coolant. Dex Cool coolant can be reused if you can keep it clean. It's a lifetime coolant. Layer upon layer. Early in the life of the Duramax, a GM-trained mechanic told me that working on a Duramax requires that you peel back layer upon layer until you reach the engine component that needs attention. For head gasket replacement, you'll need to consider these layers. Layer number 1, the air induction system, which includes the air box, air intake, and intercooler hoses and pipes. That's where we were in the above photo. The removal of layer number 1 was complete. Layer number 2 includes the cooling system hoses and piping across the engine, plus the heater hoses and turbocharger coolant hoses. Layer number 3 includes the electrical system harnesses and the electrical connectors on the engine. And layer number 4 includes the fuel supply lines, fuel return lines, high pressure fuel rail lines, fuel injection control module, and the fuel filter assembly. In other words, the fuel related stuff. Once these 4 layers have been peeled back, you can then begin to work on the engine mechanical systems, such as the head gasket replacement. There will be a couple of intermingled system components that are easier to remove and replace while working on another layer, like the crankcase vent hoses, for example. But generally, complete layers come off and go back on one at a time and in order. That's how these systems were designed, and one layer at a time. Exceptions to this general rule will be discussed when it becomes time in the step that we'll present in a later video. One of the things I recommend you do is to remove the plastic inner wheel wells. If you're working on head gaskets or replacing the fuel injectors, it's almost vital that you remove the inner wheel wells to have access to that area. And in doing so, you'll probably break some of the plastic connectors that hold the wheel well liners in place. What I did is I bought a box of connector replacements through Amazon that contained everything I needed, and you'll know approximately what you'll need by removing some of these before you begin your project. Just compare the size and then the length and the diameter of the pieces that you remove to what's available at Amazon, and then buy a set. I'd also recommend you get a tool, a removal tool, shown here in this image, that'll help you do it. It just makes the job easier, and having all the replacement parts on hand means that you'll put it all back the way that's supposed to go. Where everything goes. If this is your first time working on the engine and disassembling it and stringing parts everywhere, make a drawing or take lots of photos with your phone that illustrate where all of the miscellaneous bolts, screws, electrical connectors, and hoses are located before you remove anything. Then keep the hardware for each subassembly sorted in individual labeled containers. This will make the reinstallation process easier and less time consuming. Finding containers and labeling them takes time, but this will in the end save you both time and frustration. I like to use white paper cups, all labeled with a black Sharpie. Unless the electrical connectors mate is obvious, I use painter's tape and a Sharpie to label the connectors. Stuff large clean rags into all of the hoses and fittings as they are separated. The rags should be large enough so that there would be no possibility they'll be forgotten during the reassembly process. Each step in the video series where we replace major components will contain large, high-quality photos that you can use to give you some idea where everything goes and how everything lays on the engine during the reassembly process. And this will be a big help to you. Also, on the tables that you use to lay your parts that you've removed from the engine, if you begin from right to left or left to right, lifting the cab or removing the engine. Most of the pro mechanics and performance diesel shops I know prefer to do either one, lift the cab off the chassis, or pull the engine when replacing head gaskets. Certainly, having wide and open access to the engine does sound like an ideal, but that's not how our video guide series will be presented. I believe these two options present a lot of risk to the truck in terms of physical damage and in terms of troublesome gremlins that could plague the truck thereafter, and that those options add their own significant time and effort component. Plus, an individual isn't likely to have a vehicle lift in his garage, which makes lifting the cab an unworkable option anyway. This guide clearly shows how an individual working alone can remove and replace the cylinder head gaskets without either of those two options, and be completely successful without damaging the truck or related systems. We did two back-to-back 100% successful Duramax head gasket replacement projects during our work to compile the information we needed for this series. This concludes our introduction to the Duramax Diesel Service Guide video series. Please like this video and subscribe to our channel so you'll be notified as soon as any new videos become available. Thank you for watching.